Alright, in this demo I'm going to go ahead and show you guys how to interface with the 6 Degrees of Freedom board from SparkFun. So you can actually go and visit the website here if you want to take a look at some of the spec sheets for it. On board it has a 3-axis gyroscope and a 3-axis accelerometer. All the data sheets are available here, as well as a GitHub page with code for interfacing it with a Atmega 168 processor. I actually use this as reference for some of the code that I wrote to interface it with the Maple board, so you are welcome to look at that code for examples. Also check out the data sheets. There's a wealth of information here. I think you should probably use it. Again, you can visit the manufacturer's website. So InvenSense actually produces the ITG3200 gyroscope. The accelerometer is produced by Analog Devices. Both of these chips are available for if you want to purchase them online for your own projects. Anyway, so first things first, we got to go ahead and pull down the code. To do that, go ahead and visit my GitHub website. You can actually just search for Henry Herman on GitHub, and you can see some of the code is actually under the EE1 ADXL Maple demo project. Go ahead and copy this particular link, the read-only link. Make sure you change it to read-only. You won't be able to access it through SSH. Open up your terminal. This might be different on Windows. I haven't done it on Windows, so you'll have to figure out how to use GitHub, or you can just actually view the sources and copy them. It's up to you. But to check out the GitHub source, you basically CD to the directory you want to, and you type git clone with the link. This will actually check out the code. So if we list, you can actually CD into that new directory that it created. And you can actually see the 3 test sketches that have been downloaded. Alright, so now that we have the code, let's go ahead and use it. So here is our board. I've actually wired up this board. Here's the ITG3200 here, and then the ADXL345. You only need 4 lines to interface with this board, so because they're both digital and they use an I2C serial interface. So you need a VCC, which is the power. These run off of 3.3 volts. Make sure you don't run anything else into them. Be careful, because one of the pins on the Maple is actually a raw voltage line, so make sure you use the one labeled VCC and not VN. 1 pin goes to ground, and then 2 pins go to SDA and SCL. Really, these are open to you, because I'm not using the actual, for this I'm not using the hardware I2C. I'm actually using the bit banging wire library for the Maple board. So make sure you follow up on that. Again, so 4 lines, SDA, SCL, ground, and VCC will allow you to interface with these chips. Okay, so let's go ahead and open it up. We click on our Maple IDE, and we need to open up these sketches. So here's our code. We'll start with the ADX345. We'll go ahead and close the link. Oops. So here's our code. All the registers are here at the top, and they're made available so you can actually take a look at them. All the features, we don't use all of them, but they're here anyway. I'm using pins 9 and 5 as my SDA and SCL lines. You're welcome to use whatever pins you are. Part of the reason I use these lines though, is that these are also the same pins that are used on the hardware I2C interface. And so while we didn't use it in this particular example, it's likely that someday a driver will be written which we will be able to use. So it's probably best to use these pins. The wire library is pretty simple to use. So again, the wire library refers to the I2C interface. You basically pass in the digital lines you're interested in using. You tell it to begin. In this case, I'm starting up the serial port for outputting data to the serial port serial interface. I have a function here called setup ADXL. This actually is, again, you should probably read up on I2C if you want to understand what's happening in the code here. Wikipedia is a fantastic source. You can search for I2C with any of the major processors and you'll get example code. The basics is that it's the SD and SEL lines are pulled high. All the devices are in high Z mode and basically pull low when they want to send the data across. Here we send a power control byte. So this is the register we're going to control. We send the value in what we want to do, and we end transmission. Repeat this. This time we're sending in the address for the data format range though. So this sets the dynamic range of the ADXL345. I have some functions here that basically just read in the data points. So there's actually 2 bytes we're interested in, the high and low bytes of the ADXL. So in this case, if I first pull in the low byte and then the high byte, and then I put them together and send the data out. So these 3 functions pull out the XYZs. This is the main loop. Again, you have default values for 0. Delays for 200 seconds. You guys are welcome to set the delay to whatever you want. This is how you'll set what your sampling is. You read in the XYZ values, and then we print them out to the serial port. Let's go ahead and test this code.